In the previous tutorials for the smart video card assembly, we've done with the whole assembly and circuits wiring. To realize the control by your computer and apply the camera, some software still needs to be set. To run the card, you need to prepare a TF card and two 18650 batteries. Plug in the TF card. Turn the card upside down and then install the two batteries. Open a terminal on your PC. Type in SSHPI at your address. Here mine is 192.168.0.138 and enter the password. The initial password is from our GitHub code. Run the command git clone https://github.com/sunfounder smart video card kit for Raspberry Pi separated by low lines.git. Then pooling is done. Now you can start to set your environment on the PC. Right-click on the terminal. Click Open Terminal on the drop-down list. Then set the terminal at the upper right corner. You can see the download is undergoing on the left terminal. Install Python Thinker for remote interface. Run sudo apt-get install Python tk. Type in Y and press Enter. Then it is done. Next, install Python dev and Python smbus together. Run the command sudo apt-get install Python dev Python smbus. Type in Y and press Enter. Then run the same command on the Raspberry Pi, the left terminal. Next, set up the I2C port. Run the command sudo nano etc modprobe.d raspi /blacklist.configure. Add #blacklist I2C /bcm2708. Then run sudo nano etc modules and add I2C /dev. If there's the line already, you can skip this. Then back to run sudo modprobe I2C lowline bcm2708 and sudo modprobe I2C /dev. Check whether the I2C modules are loaded and active now. Run ls mode, grep I2C, then two groups of number will appear on the terminal. For this smart video card, we use MJPG streamer to acquire and transmit data. Now check the camera connection. Run ls/dev/vid*. We can see here the result is DV video 0, so the driver is in the normal state. Then install the software needed. Run them together. Sudo apt-get install subversion libv4l /dev lib jpg8 dev image magic. Oh, correct the DV. Here we go. Run Y to confirm. Y again. They're installing now. It may need a while. So now the installation is done. Next, we compile the code for MJPG streamer. Change directory. Then run make use libv4l2 equals to chill clean all. A few minutes then, install make dest_dir equals to /user install. If we got a message of failed install due to permission denial, add before the command a sudo. Run again. Then the software is installed successfully. Now run sudo./start.sh. Command not found. Try sudo sh start.sh. Look here, 8080, the user password, the site, and the command enabled. Then open a web browser. In the address bar, type in your Raspberry Pi address, like mine here. Then :8080, which is the port number. So the MJPG streamer page appears. On the left menu, click the Streamer tab. Then you can see the video data captured in a real-time manner. You may move something before the camera to check that. Also, you may enter the Static tab and check the static image each time you move the object before the camera. Under this tab, the process of moving won't be shown. You'll only see the picture when the object stops. Next, calibrate the car. Erect the car box on the side. Place the car middle on the box and keep it still. Make sure the wheels can move flexibly on it. Then on your PC, open a terminal. Log into the Raspberry Pi via SSH. Enter the password. Now change the directory to the car code folder. Inside it, there are two folders, server and client. And the server folder needs to be run on Raspberry Pi. Now open the server folder. Execute the calibration file by sudo python caliserver.py. You can hear and see the servos turning. Observe that front wheels should be right-oriented towards the front, which is the initial position. And the pan swivel on the mount is also toward the front, when the tilt one is faced upward. Then open another terminal. Install Git by sudo apt-get install Git. Enter Y to confirm. Then run the command git clone https://github.com/sunfounder/sunfounder smart video card kit for Raspberry Pi.git. So the code is downloaded to your PC. It's downloading now and you may need to wait for a while. Then download is done. Now change directory to folder downloaded on the Raspberry Pi. Here the client folder is running on the PC. Run the calibration client by cd client. An error message prompts that connection is refused. This is due to the wrong IP address. Now modify the address. Run the command sudo nano calibration client.py to open the client folder. So here to change the address, the value of host. Run the client calibration file again. Enter yes. The password. Yep, so a window named Raspberry Pi Smart Video Card Calibration pops up. We can see there are 3 sessions. Here is to adjust the motor, the turning swivel, and the mount swivels. Now click Run. And the wheels now are turning. However, the left wheel is running forward while the right one backward. Click Reverse on the right. So the wheels are all running forward now. Now the turning swivel. If the wheels are not straightforward, find or course turn them. You may adjust the swivel according to the real situation, and you can see the values displayed on the terminal change accordingly. After adjustment, you may take the car down on the table and make it run to see if it can run in a straight line. Fine-tune it again if not. Now adjust the mount. You can see the pan swivel is a little bit biased to the right. If the angle of your servo is too far away from the right direction, you may use coarse. Then fine-tune it. At last, calibrate the tilt servo. You may see it is slightly backward now. Adjust it in a similar way. So now the calibration is all done. Click Confirm, and the results will be displayed. The offset values in X and Y axes and the turning direction. The configuration file will be sent to your Raspberry Pi. Enter password. So it is transferred successfully. Then on the Raspberry Pi, press Ctrl and C to exit. We can see a TCP server here. Run the file by sudo python tcp server.py. So now it is ready to go. Then on your PC terminal, you can see a client app.py file. Run the file by sudo python client app.py. An error message just pops up. Also, it's the IP address issue. Find the host and modify its value again. Press Ctrl-O to save and Ctrl-X to exit. Run again. Then a seemingly familiar window pops up. It looks similar to that for calibration, see it? So on the left upper, the buttons are to control the car move in 4 directions, and on the right upper is to control the mount. Try to click the buttons and check whether the camera turns directions on the car. Click Home and it will return to the initial position. At the bottom, there is a speed slide to control how fast the car can move. Now it's time to get it on the road. Control the car with your keyboard. Try to speed it up. Oh, be careful not to fall down. In total, we need 3 terminals to control all the functions of the car. First, open a terminal for server, which is the Raspberry Pi. Log into the Pi remotely via SSH. Enter the password. Then open the server file. Run tcp server.py. Then right-click on the terminal and click Open Terminal on the drop-down list. Set it at the right upper corner. This is to run the back-end system for the camera. Also remotely log in to the Raspberry Pi. Change directory to open the MJPG folder. Then run the command sudo sh start.sh. Next, open a web browser and enter the address again. The port number is 8080, remember? Click Stream on the left menu. Now you can see the real-time image captured by the camera. Also, you can click Video LAN on the left. Find the address here and copy and paste it to the address bar. Then the window will display only the video. Set it at the left lower corner. Open one more terminal. It is for control on your PC. Here you do not need to log into the Raspberry Pi. Change directory to open the client folder. Run client app.py. Since the IP address is changed, we need to modify it again. Change the value of host. Run again. Then the control window will pop up again. Now you can see the wheels running and the camera turning in 4 directions. And you may speed up or slow down the car running. So that's all for the assembly tutorials for the smart video car based on Raspberry Pi. Hope you've got more knowledge about robotics and Raspberry Pi as well as programming from these videos. Bye!